Welcome to lesson 66. First, we're going to talk about formulas for systems of equations. So if we have a system of equations using abstract coefficients, we can create a formula that will allow us to solve any similar systems where we can just take the numbers and plug them in, kind of like substitution. So for instance, if I have a1x plus b1y is equal to c1, and then I have a2x plus b2y is equal to c2. I can solve that, and then I can create a system that will allow me to just drop in coefficients and solve without having to do all of the work of trying to find a common value and use elimination or substitution, either one. So let me try this out. Let's do the abstract calculation and find a formula that works. All right, so we developed a formula for x using a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Now, so what we did was we multiplied the top equation by positive b2 and the bottom equation by negative b1. And that gave us two opposite terms, b1, b2y and negative b1, b2y. So we were able to cancel those out entirely. And then that left us with a1, b2x minus, this is a negative sign, a2, b1x. So when we factored out x, because we wanted to solve for x, we've got a1, b2 minus a2, b1 times x equal to b2, c1 minus b1, c2. So all we did was we divided both sides by this factor that's being multiplied by x, and this is our final formula. So let's say we have a system that is 3x plus 2y is equal to 8, and 4x plus 5y is equal to 3. All right, so my a1 is going to equal 3, my b1 is going to equal 2, and my c1 is going to equal 8. My a2 is equal to 4, my b2 is equal to 5, and my c2 is equal to 3. So we can just drop these values in for those and solve. So this means that x is equal to b2, which is 5, times c1, which is 8, minus b1, which is 2, times c2, which is 3. And that's going to be in the numerator. In the denominator, we have 3, which is a1, times b2, which is 5, minus a2, which is 4, times b1, which is 2. So we can solve this way without having to do all of the other. So then that means that we have 40 minus 6 over 15 minus 8, which equals 34 over 7. That is our value for x. So then all we'd have to do is sub that in for x into one of these equations, like for instance 3, and then we would have 34 over 7 plus 2y is equal to 8. Now we could do it like that, or we could have a similar formula already set up for y and just drop these values in for y. And then we could put both of those values in and check one of them. All right, so instead of doing this, why don't we solve the system for y? So let's do that. Let's solve the system for y. In fact, that is example 66.1, is to solve the system for y. So we're going to do that together. So we are going to solve the exact same system, which is this one right here, which would give us these values right here, but we're going to solve it for y. So 66.1, we have, we're going to just create using the same exact system. So basically A1, B1, C1, and then A2, B2, C2. So now though, we're going to solve for y. And I'm going to move this out of the way just so we can have our answer over here, just so we can get it back, right? So let's solve for y this time. So to solve for y, instead of multiplying by the b's, we're going to multiply by the a's. So let's multiply by the a's, and in this case, I'm going to multiply by a2, and let's do negative a2, and then this would be a1. So then this would be negative a1, a2, x minus a2, b1, y is equal to negative a2, c1. And then this one would become a1, a2x minus a1, or I'm sorry, plus a1, b2, y, and that would be a1, c2. So these would cancel, which means we're left with a1, b2, y minus, I went ahead and just did this one second because then what that does is it makes it to where we don't lead out with a negative, which we know is kind of not easy to do in math, right? So then this is going to be a1 c2 minus a2 c1. Okay, so now we could factor out our y, and we get a1b2 minus a2b1 times y is equal to a1c2 minus a2c1, and then we divide. So y is equal to a1c2 minus a2c1 over this factor, which is a1b2 minus a2b1. So now we can drop in the same values and find the value for y. So if we go back to our system, the same system that we used earlier, we can get our values. So y is going to be equal to, our a1 value is 3, our c2 value is 3, minus our a2 value is 4, and our c1 value is 8. Our a1 value is 3, and our b2 value is 5. Our a2 value is 4, and our b1 value is 2. So that becomes 9 minus 32 over 15 minus 8. So then that would become negative 23 over 7. All right, so that's a whole lot faster than finding, having to find x and then having to find y. If we just write these formulas down, there's our x, our y formula, and here is our x formula. We don't ever have to solve another one of these through substitution ever again. How awesome is that? Now this is something that when you get to college algebra, this is something that they will reiterate. They'll give you this formula for solving a system of equations instead of the other. You will do that first, but then you will learn how to do this again. And it is one of those cool things that you get to figure out in math, how it all kind of links together. So we can check our work. We can make sure that it is what it says it is. So 34 over 7 was the x term, right? So 34 over 7 is the value for x, and y is negative 23 over 7. So let's see. Let's make sure. So 3 times 34 over 7 plus 2 times negative 23 over 7 should equal 8 if everything is correct. So first of all, let's do 3 times 34. That'd be 90 plus 12. That'd be 102 over 7 plus, or I should say minus, 2 times 23 would be 46 over 7. All right, so 102 minus 46. Well, 100 minus 40 would be 60, right? And all right, let's just do it on the calculator. I can't do it all in my head. I can't do everything in my head, believe it or not. I'm not that smart. 102 minus 46 is 56. 56 over 7 is equal to 8. So how about that? Checks out. Perfect. So you see it's mathematically sound. So you can use this formula for y and this formula for x in order to solve any of your systems of equations that are in the form of two variable systems, x and a y. All right, and that's when they're both in the first degree. If they're not in the first degree, then you're going to have to do something else. But as long as they're in the first degree, some term x plus y equals some value, and you have two of them, then you know that you can use these two equations, these two formulas, to just drop your numbers in, and Bob's your uncle. All right, let's look at 66b. You're going to have a couple practice problems using these formulas, and then you're going to watch the video for 66b, which is about phase shifts and period changes, and that has to do with trigonometric functions, and I will see you in that video.